Another type of problem that uses this same equation, Q equals mc times delta T, is a more qualitative type of problem. So instead of plugging in all of the numbers, a problem like this one, we have the same mass of all these substances from this table, and they all start out at the same temperature. Which one is going to reach the highest final temperature when you add the same number of joules to each? So the wrong way to work a problem like this is to make up numbers for the heat and the initial temperature and then plug in all your C's and then calculate and figure out which one is the highest final temperature. A better way to do that is to look at this equation and solve for the variable you want, which is delta T is directly related to that final temperature. So because all of these substances started at the same initial temperature, the one that's going to reach the highest final temperature has to be the one that has the largest delta T. That's what we're looking for. If we get the largest delta T, we must have the largest final temperature. Now, each one of these had the same number of joules added to it. So that means the Q is the same for each of these. We also have the same mass. So Q is the same and M is the same. The only thing that changes when you switch from lead to gold to silver, the only thing that changes is the heat capacity C. And notice C is in the denominator of this equation. If we want to end up with the largest delta T answer, we would plug in not the largest, but rather we would plug in the smallest C. Because if we have the smallest C, when we divide from the denominator, dividing by a smaller number is going to give us a bigger final answer. So the chemical that has the smallest heat capacity is a tie between the first two, lead and gold. So both lead and gold would reach the same final temperature in this example. Think about a problem like this and switch it around. What if they had asked you which one would reach, instead of the highest final temperature, which one would reach the lowest final temperature? The lowest final temperature, instead of the largest delta T, we would in that case want the smallest delta T. And the smallest delta T, Q is still the same, M is still the same. What changes is the heat capacity C again. So water at the other extreme has the largest heat capacity. Water would have the smallest delta T, so this would have the smallest final temperature.